Greetings everyone, my name is Dr. P. Pavan Kumar and in this video I am going to explain you the introduction for the lasers. And this is the topic in case of advanced engineering physics. Now we'll explore that. So in this video I am going to explain the contents acronym of laser, basic definitions that includes absorption, spontaneous emission, stimulated emission, metastable state. Along with that, characteristics of laser and that other basic definitions like population inversion and pumping. Now let's move to the acronym of laser. It's a very important thing, that is laser full form. That's L is a light amplification by stimulated emission of radiation. Means here the light is a form of energy get amplified by the phenomena of stimulated emission and that's radiated out. That's taken as a laser. Now we will see what stimulated emission, how the amplification happens in this chapter. So it's a full form or acronym finally is light amplification by stimulated emission of radiation. Now let's see the absorption. Absorption is nothing but in general sense it's a taking. Now, if I consider two energy states E1 and E2, E1 is a ground state and E2 is an excited state. So, in general, the more number of particles were observed in case of the ground state, that is E1 state, because the more stable in that state. For that, if we supply any energy and the energy must be equal to the difference of these two energies, that's E2 minus E1. If that energy is supplied, the ground state particles absorb that energy and they will move to the excited state. This phenomena is called absorption. We can define it as absorption is a process in which specific energy is absorbed by particle resulting in excitation of electron from lower energy state to higher energy state. And another one will see the spontaneous emission. The excited particle cannot stay there for sufficiently long time because the excited states are unstable. So after 10 power minus 8 seconds, that will come back to the original state, that's E1 state, without using any external energy. That phenomena is called spontaneous emission. Means after its lifetime, that's around 10 power minus 8 seconds, that will come back to its original state E1. That phenomena is spontaneous emission. When that moves from excited state to lower state, that emits a photon of energy, again that's a gap E2 minus E1. So we can define it as it is the process by which an excited particle independently returns to lower energy state after its lifetime and emits a photon in the process without any external energy for the de-excitation. So here the thing lifetime, how can we define a lifetime is? So it is the time taken by the particle to stay in excited state is called lifetime of the particle. As I said before, that's around 10 power minus 8 seconds. Now we'll see the another definition, that's a stimulated emission. The same scenario I considered two energy states E1 and E2. This E1 is a lower state and E2 is an excited state. So suppose if I don't want to keep the particle here for sufficient, that's lifetime 10 power minus 8 seconds, before its lifetime I want to get the particle to the lower state. So give supply energy to the excited particle and this will stimulate the particle to the lower state before its lifetime. So as a result, two photons gets released and one is as usually the applied one and other one is because of the de-excitation. And interesting thing here is these two photons are coherent. Means these two photons will have same phase and same frequency. Everything will be same for these two photons. And this is the principle in case of lasers. And we can define it as stimulated emission is a process by which an incoming photon causes the excited particle to come to the lower state and a second photon gets released and these two photons are in phase. We can call it as they have a same energy, same phase and they move in a same direction. And this is only the principle in case of lasers. Now we'll see the another important one in lasers, that's a metastable state. So if I consider three energy states, let it be E1, E2, E3, right? And E1 is a ground state, E2, E3 are excited state. As per our previous discussion, the stability or the energy, the time for the particles to stay in excited states is 10 power minus 8 seconds. As I said before, it's taken as a lifetime of the particle. But in some cases, what happens is, in few energy states, the particles will be stayed for sufficiently long time. The 10 power minus 8 seconds. So more than 10 power minus 8 seconds. Again, that's around 10 power minus 3 to 10 power minus 4 seconds. And that energy state is called metastable state. In the production of lasers, it's very, very essential. Without metastable state, we cannot produce a laser in a materials. Now we'll see the characteristics of laser. So to understand the characteristics of laser, we just imagine the difference between our normal light and a laser light. So the list is high incoherence, high monochromaticity, high directionality, high intensity. These four are the major characteristics of laser. Let's explore these four characteristics. Now, if we see this image, we can understand that it's a normal light. It spreads in all the directions and something like that. Now, if I take this is what a laser light which moves in one. So think the direction or think the differences of these two light sources, those become a characteristics of these lasers. Now, if first one we said high monochromaticity. Why this consists of high monochromaticity? Because in case of laser, de-excitations happens between the same energy states. Because of that, they are going to have a high monochromaticity, means all the photons here will have same wavelength. That leads to high monochromaticity. And if you observe the laser light which moves straight, so all the photons are moving like a straight line. They are moving in a same path without much deviation. There is no deviation here, something like this. So why this happens means because of laser is a coherent, and this leads to high coherence. And as all photons are focused at same point, that leads to another characteristic, that is high intensity. So, and another one here we'll see, as I said before, the same energy state, the de-excitation happens between the similar energy states, and the photons emitted are same phase. That leads to high coherence. Because of all these things, lasers show a different characteristic. So laser also called as a coherent source. And another definition we will see here is a population inversion, or we can also call it as inverted population. Here, suppose if I consider three energy states, E1, E2, E3. As usual, E1 is a ground state, E2 is a first excited, and E3 is a second excited state. Along with that, I also consider N1 number of particles in lower state, N2 number of particles in excited, and N3 is the number of particles in E3 state. So in general, to get good stability, the numbers in the number of particles in the lower state are more than the E2 state, and number of particles in E3 are more than the number of particles in this one. Now N1 is greater than N2 and N2 is greater than N3. This is a in general thing. But suppose if I use any process, and by that process if I excite the ground state particles, suppose if I get the thing like this. So if you observe this image carefully, so here more number of particles are observed in E3 state than E2 state, means N3 is greater than N2. So we observe more number of particles in E3 state than E2 state, means excited state will have more number of particles than lower state. This phenomena is only called population inversion or inverted population. This can also be represented something like this. The length of this is represented the number. So this is the situation before population inversion. Lower energy state have a more number of particles than excited. Now after the process or after the population inversion, more number of particles in excited state than lower state. That phenomena is only called population inversion. So in simple, number of particles are more in higher energy level than lower energy level, and at that time the lower state is called negative temperature state. And here negative temperature doesn't mean that minus 20 degrees or minus 30 degrees centigrade. It doesn't mean that. It's a lower state, means excited state more number of particles are there. In the lower state we have a less number of particles. This phenomena is only called population inversion. This is very essential thing for the production of lasers. Now let's see the another one, the phenomena pumping. So just now we had discussed the phenomena of population inversion. So to get more number of particle in excited state, we are using the process, and that process is only called pumping. So in simple, pumping is nothing but giving energy to the ground state particles and excite them to the next levels. So by that automatically the lower state will have less number of particles, and that leads to population inversion. So pumping is a process used to achieve population inversion. That is what a pumping. And thank you everyone. This is the basic introduction for the lasers, and happy learning.